This is how to read an electric motor wiring diagram. The real thing, right here on screen. A three-phase induction motor, its terminal box, and 6 leads inside it. It looks like a mess of letters and little metal bars. It is not. Every motor diagram is really just 3 questions. Which lead is which? Where do the link bars go? And what does the nameplate say? Answer those 3, and any motor connection, star or delta, falls out in seconds. Let me show you exactly how to read it. Start where the wiring actually happens, the terminal box on the side of the motor. Open the lid on a standard 3-phase motor and you find 6 terminals, not 3. That is the first thing to read. 3 windings, and each winding has 2 ends, so 6 leads in total. The modern marking is U1, V1, W1 across the top, and U2, V2, W2 across the bottom. On older motors, the very same 6 leads are marked T1 through T6. Do not let that throw you. U1 is T1, and so on. Same motor, older labels. Here is the key you must know to read anything else. The start of each winding and the end of each winding sit at opposite corners. U1 pairs with U2. V1 pairs with V2. W1 pairs with W2. Those 3 windings are the whole motor, and how you bridge their ends decides everything. The first way to connect those 6 leads is star, also called Y, because it looks like the letter Y. To read a star connection, look at the bottom row. In star, the 3 winding ends, U2, V2, and W2, are all bridged together with the link bars into one common point, called the star point or neutral. Nothing else connects to it. Then your 3 supply phases, L1, L2, and L3, land on the top row, on U1, V1, and W1. That is star. All the tails tied together, the supply on the heads. Why does it matter? In star, the full line voltage is shared across 2 windings in series, so each winding only sees about 58% of the line voltage. That is the lower stress connection. It is used on the higher supply voltage, typically 400 volts. Bottom row bridged, top row fed. That is a star motor. Quick note before we do delta. Every diagram in this video is drawn in a free editor that runs right in your browser, CircuitDiagramMaker.app. No install, no sign up. Open it in a second tab and follow along. The second connection is delta, and this is where people misread the link bars. In delta, you do not tie the ends together. Instead, the end of one winding joins the start of the next, all the way around, so the 3 windings form a closed triangle. On the terminal box, that means the link bars go on the diagonal. Read it lead by lead. U1 links to W2. V1 links to U2. W1 links to V2. 3 diagonal links forming the triangle. Then the supply L1, L2, L3 connect onto those 3 join points, not on empty terminals. In delta, each winding sees the full line voltage. That is more voltage per winding, so delta is used on the lower supply voltage, typically 230 volts. Diagonal links supply on the joins. That is a delta motor. So, star is tails together on the low stress high voltage. Delta is a diagonal triangle on the higher stress low voltage. Same 6 leads, 2 completely different link bar patterns. Now the question that decides everything for your supply: do you wire this motor in star or in delta? You do not guess. You read the nameplate. On the side of every motor is a metal plate, and the line you want reads something like 400 volts, then 230 volts with a Y symbol next to one and a triangle next to the other. That is telling you, connect in star, the Y, for 400 volts, and connect in delta, the triangle, for 230 volts. Match your actual supply voltage to that plate, and the plate tells you the connection. The same plate also gives you the full load current in amps, the power in kilowatts, and the speed in RPM, everything you need to size the cable and the overload. Read the plate first. It is the instruction sheet for the terminal box. Reading the diagram also tells you how to change the direction it spins. To reverse a 3-phase motor, you swap any 2 of the 3 supply leads. That is it. Take L1 and L2 at the terminals and swap them over. Leave the link bars exactly as they are. Star stays star, delta stays delta. Swapping two of the three phases reverses the rotating field, and the motor turns the other way. You never touch the third phase, and you never touch the internal links. Two supply leads swapped. That is the whole reversal, and being able to read that off the diagram is why the diagram matters. Not every motor is three-phase, so read a single-phase one differently. A single-phase motor has two windings, not three. A main, or run, winding, marked U1 and U2, and an auxiliary, or start, winding, marked Z1 and Z2. On its own, a single-phase supply cannot start the motor, so a capacitor sits in series with that start winding to shift the current and get a rotating field going. So when you read a single-phase diagram, you are looking for 4 terminals, not 6, U1, U2, Z1, Z2, and a capacitor across the start winding. Line and neutral feed both windings. The capacitor does the starting. Fewer leads, a capacitor, and no star or delta choice to make. Here is a real motor wiring diagram, open straight in the editor. This one is a single-phase motor circuit. The supply coming in through a breaker, an on-off switch, and an overload out to the motor with a run capacitor across the windings. Follow any wire, end to end, and nothing is hidden. That is what reading a clean drawing gives you. Every terminal and every link laid out in the open, exactly the way you would read the real terminal box. And here is something a plain drawing cannot do. Check what you have read with a real simulation. I will open a ready-made motor starter template, already wired. There's a genuine circuit engine inside the page. Hit Simulate, run the DC analysis, and real voltages and currents land right on the wires. If you had read a connection wrong, the numbers would tell you before a single wire got crimped. That is a check no paper diagram can give you. These motor wiring diagrams all live on the site, free to open, print, or copy as your own starting point. There's a whole library of motor and control diagrams alongside them, and a full symbol reference, all linked in the description. Grab the one closest to your motor and read it terminal by terminal. So that is how to read an electric motor wiring diagram, start to finish. Read the terminal box first. 6 leads on a 3-phase motor, U1 to W2, older T1 to T6. Star ties the 3 ends together and feeds the heads on the higher voltage. Delta links the windings into a diagonal triangle and feeds the joins on the lower voltage. The nameplate, 400/230, Y or triangle, tells you which one to use, along with the full load current, kilowatts, and RPM. Swap any 2 supply leads to reverse. And a single-phase motor is just 2 windings for leads and a capacitor. Open the free editor, grab a motor diagram, and read it for yourself. The link is in the description. Subscribe for a new wiring diagram explained every week, and I will see you in the next one.